Assalamualaikum and a very good evening, ladies and gentlemen. A very warm welcome on behalf of the Organizing Committee International Constructions Week at FTK 2022 to our guest speaker this evening, Technologist Agilarajan Selvarajah, Associate Ranhill Bersekutu Sdn on this virtual platform. On this virtual platform at slide 4 with the title Road Safety Audit for Recoda Project. Without further ado, it's now my pleasure to invite IR Technologist Muhammad Hari bin Osman, our moderator for today, to lead our webinar Road Safety Audit for Recoda Project. The floor is yours.
Okay, thank you, MC. Miss Siti Nuashikin binti Ahmad Salan. Okay, Assalamualaikum and a very good evening to everyone. Okay, first of all, I would like to say thank you. Thank you for visiting today's webinar. Okay, my name is Muhammad Hari bin Osman. Okay, I am an Industrial Fellow at Faculty of Engineering Technology, UTHM. I will be a moderator for this slot and I'm glad to welcome to our distinguished speaker, Technologist Agilarajan Selvarajah, Senior Engineer at Ranhill Bersekutu Sdn. Okay, speaker will present about the road for Recoda, the road safety for Recoda project. Okay, now I would like to introduce about TS Agilarajan Selvarajah background. Okay, he currently pursues Doctor Business Administration at University Malaysia Sarawak, UNIMAS. He obtained his Master of Highway and Transportation Engineering from University Putra Malaysia, and he has completed his bachelor degree of Civil Engineering from University Putra Malaysia. Okay, he also has industrial experience more than 10 years, and most of the experiences were related on the road, highway, transportation engineering. And now his current position is senior engineer at Ranhill Bersekutu Sdn. Okay, the project that he was involved at Ranhill Bersekutu Sdn. Such as Kuching Urban Transportation System, Line 1, Second Trunk Road, Sarawak, Package C1 and C2. When he worked at MSZ project Sdn. As engineer, he also was involved in a Pen Borneo Highway Sarawak project. Okay, this is a little bit about Mr. Agi background. Okay, before we start, let me explain how the audience can talk to us during the webinar. Okay, if you have any question during the presentation, just write them to chat room or you can wait until Q&A session. Okay, Q&A session will be at the end of the slot and the presenter will answer all of your questions. Okay, without further ado, it's now my pleasure to invite TS Technologist Agilarajan Selvarajah, or I call it as a Technologist Agi, Senior Engineer from Ranhill Bersekutu Sdn. To give his presentation. Okay, TS Agi, the floor is yours.
Hello guys, how are you? So everyone can hear me clearly? You guys can hear?
Yes, I can hear you.
Okay, perfect. Okay, good afternoon, ladies and gentlemen. So how are you today? So, okay, since our talk is going to be online, make sure you get your coffee. If you want to get your coffee or your tidbits and everything, put it close to you. If you have anything in particular, do ask me. If I can't answer, please leave your email address. I will answer. I will reply your emails later after the session. Okay, then if there are any participants who are driving, kindly stop your car at a proper place to listen to this webinar, or you can get the recorded version later from the secretariat. So because safety is first, safety is always first. And yeah, without further ado, I'd like to get into our sharing today. So this will be more on an experience sharing rather than a lecture. So let's not make it too formal, and yeah, let's go into it. So my name is Agilarajan Selvarajah. So I'm currently working as an associate in Ranhill Consulting Sarawak. So yeah, so Ranhill Consulting is a big company which is Our HQ is situated in KL, Jalan Tun Razak. So yeah, now let me give a simple introduction about my company before we go into our presentation. Firstly, we are, as an overall, we are called Ranhill Bersekutu. Who we are? We were established in Kuala Lumpur in 1973. Then Ranhill Bersekutu was incorporated in 1981. And Ranhill Consulting Sdn Berhad was established in 1996. And in 2016, we have established Ranhill Consulting Sarawak Sdn Berhad. And now in 2021, Ranhill Bersekutu is fully acquired by KLSE listed Ranhill Utility Berhad. So, and okay, Ranhill Bersekutu has a paid up capital of more than 230 million. We have 49 years of experience in construction industry, and we had projects over 21 countries across the world. So, and our scope of work, what we do is everything. We actually do everything related to engineering, from land developments, buildings, utilities, environment, BIM, infrastructure, EPCC, and everything. So, and basically, these are the discipline. We are multidisciplinary, so we are going to focus on transportation today. And this and our topic will be under the technical audit here. Okay, now road safety audit. So, what is road safety audit? So, this is based on the guideline for the safety audit of roads and road projects in Malaysia. Formal examination of planning, design, and construction of a road project and of the characteristic and operation of an existing road by independent and qualified examiners to identify any potential unsafe features or operational arrangement that may adversely affect the safety of any road user. So basically, the main reference for road safety audit is this book. This is what we use, road safety audit. This is published by the JKR, Jabatan Kerja Raya Malaysia. Okay, so this is the book which we use as a basis for our road safety audit. And this is our guideline. Okay, next, why? Why we do road safety audit? Firstly, we have to detect and eliminate unsafe features. So we will do it in stages by stages because we have 5 main stages of road safety audit. So then we will determine all the problems and we will slowly mitigate it. We will propose mitigation, or the consultants will propose the mitigation and we will check on it. So basically, why? It will reduce the likelihood of crashes and then reduce the severity of crashes, reduce the cost of remedial works, and then reduce the cost and social impact, okay, and increase the road safety prominence. Basically, that's why. Okay, who? Okay, normally who will do this road safety audit? So the person supposed to be independent personnel, must be accredited, and have certain skills. First, in road safety engineering, traffic management, road design, and accident investigation and countermeasure. This person should be able to foresee potential safety problems in many various viewpoints from the road user and designer. So in Malaysia, for the moment, there are only 41. This was an updated list on February 2022, yes. So there's only 41 road safety auditors in Malaysia for the moment, and these are the list of them. Okay, next. After who, we need to know when. Okay, now, as I told you just now, there are 5 stages of road safety audit. The first stage is normally on feasibility and planning. Second stage is PED, preliminary engineering design. Third stage will be detailed engineering design. Fourth stage will be broken into 3 parts. First is TMP, traffic management plan. Second will be, this is during the construction, when approximately 50% completion of the construction. Then part 3 will be pre-opening. before they open the road to the public, and stage 5 will be after construction and during operational stage. Okay, now where will it be done? So the stage 1 will be basically a desktop study where the consultant will give us the conceptual report or feasibility report. We will study them and we'll do a site visit based on our studies and give our comments on it. Secondly, stage 2, when the consultant submit the preliminary, based on the stage 1 report, which comments we have given the consultant, they will incorporate in the preliminary design, and they'll submit their stage 2 report to us. Stage 2 is not report, if they will give us the preliminary designs. So we will check the preliminary design, and normally the stages here, what will happen here in this stage, consultant will submit, the road safety auditor will give their comments, and then if there is any dispute between the consultant of the project and the road safety auditor, we will request the client to make a decision. That's why we have a decision meeting. So upon the decision, we will move on to stage 3. Stage 3 is detailed engineering design. This is also desktop study whereby the whatever comments and the decision meeting, the consultant will do their detailed engineering design and submit to us. We will review the detailed engineering design. So when we review the detailed engineering design, we will give our comments and everything. And then again, there will be a decision meeting. Okay, after the decision meeting, we will not go to stage 4 immediately, because stage 3, we will do another part will be a compliance audit, compliance on whatever was discussed in stage 3, because stage 4 is already entering construction. So whatever problem we can resolve before the construction, we will resolve them first. Okay, now in stage 4, as I said, there's 3 parts. So the first part, we wouldn't need any site visit. Normally, we don't do any site visit because just TMP review. The consultant will submit the contractor's traffic management plan at site during construction. We will review it. Then stage 2 is to stage 4 part 2. We will actually have a site visit there. We will check what is the. We will go for verification whether they follow the TMP fully or not, and also we will also if there are some components which has been completed, we will do our audit on verification audit on the compliance to the drawings, construction drawings. Okay, then part 3 will be stage 3. Part 3 will be, we will do upon approximately 95% completion. But nowadays, we prefer to, for Recoda projects, we prefer to do the audit when all the signages and road marking has already been installed and marked. Because when we go, because normally we do have the night audit as well for stage 2 and part 2 and part 4, part 3. So we need to see the retro-reflective of it, whether at night people can see or not. Okay, we'll get to that more later. Okay, stage 5 is also desktop study and site visit, but it's more on site visit. Okay, so we have done the where. Now we'll go to how. Okay, how we are going to discuss about this today is we are going to talk about Recoda projects. Okay, Recoda is a regional corridor development authority under the Sarawak government and federal government. Under them, they have 3 main agencies: URDA, Upper Rajang Development Agency, and NRDA, Northern Region Development Agency, and HDA, Highland Development Agency. Cumulatively, they have 263 infrastructure projects all over Sarawak. The reason of doing this is to make their economy better. There's the regional economy corridor. This is the regional economy corridor. So they want to better the economy of the local areas there. What is best? The best way to boost the economy is to provide proper infrastructure there. So this is the figure. So I'll move forward. Okay, now today we will be talking about the Northern Region Development Agency's project. So we'll focus on a place called Lawas. Lawas is strategically located between Brunei, Sabah, and Sarawak and Miri. So it is a very special location, and the potential, economical potential in NRDA will be aquaculture, oil and gas, livestock, and tourism, because there are a lot of virgin jungles, waterfalls, and a lot of tourism hidden gems to be explored there. Okay, now the project which we would like to talk about is development projects under NRDA package 2, and this project is project number 11. Proposed construction of new road from Banting to Kampong, Belimbing, and new Tanjung Lagoon, Datuk Tai Road, Lawas. It's located in Lawas. Lawas is under Limbang Division. Okay, now, so we are going to, since we are just going to just get a basic idea of this, I'm going to take the simplest project there. This will be it. So there will be a potential future economical needs of this area. So they're providing this small road as to supplement the to actually boost the infrastructure and the economy at that area. Okay, first, let's go to stage 1. Stage 1, there is few things we will check. We will review during the stage 1, our road safety audit stage 1. So firstly, we will review on the traffic planning strategy, route standards, road network effect, general geometric standards, outline for provision for users and with special needs, alternative alignment, and public transport. First, let's go to traffic planning strategy. So what is traffic planning strategy? So when you propose a new road, how it impacts the existing network? So will there be any potential impact to the road safety of that whole area? That is it. So basically, we will check on that. So next, route standards. Okay, basically, you can see route standards. Okay, now we'll go to this. This is a picture. I mean, this is something which I extracted from ATG 86 Pindaan 2015. Okay, here we can determine the classification of the road by using the ADT, the traffic volume. So what is the road standards? Is it rural 6? Because there is a hierarchy there. Either from the lowest will be rural 1, the highest will be rural 6 for rural roads, and for urban 1 to urban 6. Urban 6, since you guys are there, Elite is urban 6 road. R5 will be more on West Coast Expressway, will be urban rural 5 type of road. And if you can go to your normal arterial road in front of Pariat Raja, that road will be classified under R3 roads. It used to be R3. I'm not sure whether they have upgraded to RU3 now or not. I'm not sure. So it used to be R3. Okay, now, next. From here, from knowing the standards, we can determine the speed of the road. The speed of the road, okay, since this is a rural project, the 3 main criteria, the criteria of determining the speed is terrain. There is flat terrain, rolling terrain, and mountainous terrain. So flat terrains are terrains which has basically about less than 3% of gradient. Rolling is 3 to 25%, and mountainous is more than 25%. So now we are doing an R1, and our terrain is flat. So it's 40 kph. Okay, now, next, let's go to road network effect. Road network effect is implication to existing accesses. Normally in each road, if you want to do any roads, there'll be existing accesses to houses, to plant, to a kebun, or small things, even for a temple, to a mosque. Example, these are the examples. So, and next, we have to check the hierarchy of the connecting road. There'll be other roads where the road connects. So for instance, you're doing a R1 road. So what road is you cannot connect a R1 road directly to a UR5 road or something like that, you know. So it will be, you need to propose a lot of mitigations to avoid any potential hazards there. Then the junction capacity, and then number of direct access, because if you have too many direct access to the road, what will happen that it will reduce the road's capacity. So sometimes you need to provide service road. Normally for R5 roads and everything, when you are doing that, you need to provide service road to avoid this problem. Then finally, we will be talking about acceleration, deceleration lane. So when you go out from a junction, that junction, if for instance the road, the current road speed, you are in a road where you are traveling at the speed of 30, the road which you are going to enter is this road speed is about 60. So you need to have an acceleration lane so that you can easily accelerate and go there. So acceleration lane can be calculated by using the add rate interchange of JKR 11/87. Pindaan 2017. So that's the thing. Then we'll go to general geometric standard. Okay, for these roads, the main standards we used will be 8/86, as I told you, a guide on geometry design of roads. Next, we use a guide on the design of at-grade intersections. And we are using the guide, this is special only in Sarawak, guidelines for the design of low volume rural roads, LVRR. This is special because we only use in Sarawak, where if you notice that it is more lenient compared to these books. The for R1, the lane width, according to ATA 8/86, minimum 5 meters. But in LVRR, there's allowance to go until 4.5 meter lane width. So example, that's one of the example. Okay. Next, outline for users with special need. These are like pedestrian, these just walkways and motorcycle lane, bicycle lane, walkways. And, normally when you have walkways, nowadays there are a lot of facilities built outside which are not inclusive. Inclusivity is very important nowadays, whereby people with wheelchairs have problem because of the curbs too high, because they don't provide a proper depression on the curb so that the wheelchair users cannot go up. So as future engineers and designers and contract personnel, I believe that you guys must take this into consideration, because inclusivity is very, very important. Okay, next, alternative alignment. For instance, you have one alignment, you have alternate alignments for us to study, so we can propose which is better. And public transport, because this is a new road, we don't have existing public transport there, so you don't have bus stops or anything. So that will be the other things. Okay, now let's go to stage 2. Stage 2, we'll be studying on design criteria, typical cross-section, horizontal and vertical alignment, and its combination. It's very important. Huh? And then intersection, climbing and overtaking lane requirements, traffic sign, road marking and furniture, and traffic management plan. Okay, now let's go to design criteria. Okay, design criteria, I told you just now, these are the things which, how you decide your speed of the road by using the terrains. Okay, this is for rural. For urban, we use how congested the area is, how free the road is. There's type 1, type 2, and type 3. So that is another thing we have to look into. Okay. Next, we go to typical cross-section. Okay, this is a commented sheet. So what we do is we have commented on the problems which there is here. So they have provided these different projects example, because I wanted to show you more on how in a broader spectrum. So this is for the R3 road, so whereby the lane width is 3.25 meter. Okay, the problem, it looks very nice and everything here. The only problem is Guardrail, the positioning of the guardrail. They have positioned the guardrail very well. No problem. Normally, you need a backing of 0.6 meters behind here, based on the RIM guidelines for guardrails. I mean, for longitudinal barriers. So you need that backing. You know why do we need that backing of 0.6? Because when, guardrails are they're not rigid barriers, you see, they are semi-rigid barriers. They are flexible barriers, actually. They're not semi-rigid, they're flexible barriers. So when car or vehicle hits them, when they hit them, they have the tendency to divert them back into the existing road. So dia akan, when you just go and bang it, it will actually move you back to the existing road. So when it moves it will deflect. When it deflects, it needs the backing there. So that is the thing that you need to provide. So this is for another one for U1 road. So this what normally in the ATJ, A/86, they have defined the minimum road reserve width for every criteria, every hierarchy of road. So this was insufficient, so that we have pointed out. This is the example where we have we annotate our comments on the drawings. Okay, next, let's go to horizontal and vertical alignment. Okay, what do you know about horizontal alignment? I think I will show you in RSA stage 3 later. Okay, but this is the basic things. Okay, for horizontal alignment is something you see from the plan view of the alignment. So alignment is normally, what is there in alignment, horizontal alignment? There's only 3 important things. That will be, one is tangent, then curve. You have one tangent, you can put a curve there. And then between the tangent and curve, there will be transition. So you cannot place the curve suka hati sahaja. You have to refer to this. There are some criteria. For example, you can refer to RIM guidelines on geometry. You can refer to ATJ guidelines. You can also refer to ASTO. These are the 3 things widely used in Malaysia. So our projects, we use ATJ, Arahan Teknik Jalan. So this is the sample. Okay, let's just go for a example. For a road speed of 40 kph, the minimum radius will be 45 meters. So with 45 meters, the percentage of super elevation will be 10%. So these are for horizontal. Let's go to vertical. Vertical, normally if you see vertical alignment, right, you go upgrade, then you go downgrade, then you go upgrade. So when you go upgrade and downgrade, you will have a crest there. Crest. So in order to design the crest, you need to calculate the K value. K value is also can be defined as the relative radius of it as well. So you'll get the crest value. Similarly, when you go for downgrade and you want to go from downgrade, you want to go upgrade, you'll have a sag. So this is the sag value minimum. So these are the minimum K values for sag and K values for crest. Okay. Then intersection, I'll go more detail on intersection in RSA stage 3. Then the climbing and overtaking lane requirement. Climbing lane. Okay, if you guys have noticed, in Plus Highway, you have climbing lane in Port Dickson, because there is a small upgrade over there. You have a climbing lane there. Previously, before it became 4 lanes, it used to have it was already 4 lanes there, because it was 1 lane for climbing. So normally we provide climbing lane for when you exceed a certain percentage of grade, you need, because you have heavy vehicle traveling, you don't want them to be a problem to your road capacity there. So what you do, you have a climbing lane. So this where this heavy vehicle can happily and take the sweet time to climb the grade. So that's the thing. Overtaking lane, when you have a single carriageway, you will have overtaking lane at certain intervals. So to accommodate people to, if you want to go faster, there are the places for you to overtake. Okay. Okay, now let's go to traffic signs, road marking, and furniture. Okay, these are the example in this particular project. Since this project was completed, this picture was taken during road safety audit stage 4 part 3. Okay, now there are other standards, ATD standards we can use for road safety or to review and to design traffic signs, road markings, and furniture. I believe that this is one of a good guideline. It's called Standard Drawings for Roadwork, Section 6, Road Furniture. This particular standard is very helpful if you want to study, if you are interested in furthering your career in road safety or road design or anything to do with road. I think it's a good book for you to just have a look. Okay, and then these are the road marking. This is not conventional. The reason I put this picture is not a conventional arrow because it's a edited one because this road is a R1 road, so it's quite constrained, and this is a special arrow we have amended to cater the site constraint. And this is basically signage, example of signage picture. Okay, then TMP, I will explain further in road safety audit stage 4 actually. Okay, now road safety audit stage 3. Design criteria, typical cross-section, I think you have seen just now. Now I'll show you something else for horizontal and vertical alignment. Okay, this is the alignment control plan for horizontal alignment. Okay, now what is here? What is important here is you can see this is the tangent which I told you just now. Another tangent. This is the curve, and you can see here CS is curve to spiral, spiral to tangent, tangent to spiral, spiral to curve. So it will go. This is the normal arrangements. So one of our comments here is 3V not complied. What is 3V? 3 is 3 lah, number 3. V is the speed, the design speed of the road. The design speed of the road can be anything. For this road is a 70 kph road. Minimum V is 70. 3 times 70 is 210. The minimum V should be 210. So they have only provided here about 113, so it is not sufficient. So we have commented it. So that's an example of it lah. Okay, now intersection and junctions. So this is one of the intersection. We have commented. This is when I was talking to you about the acceleration lane, deceleration lane. This is the acceleration lane. This is actually the taper. This is the acceleration lane calculation lah. So acceleration, this will be a deceleration lane. From here, it's going into it. It's a deceleration lane, and this will be an acceleration lane. Oops, sorry. This will be an acceleration lane. So this is it. This is based on our comments, and this is a sample of our comment for this particular project. Okay, the climbing rain and everything, we have spoke about it. TMP, we'll talk about in stage 4, part 1. Okay. Next will be RSA stage 3 compliance, which I told you. RSA stage 3 compliance based on the decision meeting with the client. So the consultant will amend the drawings and reports and submit to us. We will do a compliance checking on it based on our previous comment, based on the consultant's responses, and based on the decision of meeting. Okay, now let's move to stage 4. Okay, stage 4, part 1 and part 2. Okay, for this particular project, we are not required, because a small project, Recoda has requested us instructed us not to proceed with part 1 and part 2. But what is part 1? Part 1 is to review the compliance of the TMP requirement. TMP means temporary traffic management plan, sorry. So, and verification audit for RSA stage 3 compliance. When we say the stage 3 compliance, if there are other things which the consultants still have not met, this is the time for them to improve it, because we will be auditing the construction drawing here. Okay. Then part 2 will be verification of TMP on site and work completed. So this is where we will do the site visit. Despite this, part 1 is not required for this project. We have still did something to when the consultant and the contractor submitted us the TMP, we still audited it and gave them our feedback. This is a sample of it. So what they're supposed to have, all the signage they're supposed to have and everything. Okay, now we'll go to stage 3, part 3. Okay, road safety audit stage 4, part 3. So what are the things you check here? You check on the grading, alignment, cross sections, and then you check on the roadway features, traffic signings and road marking, road safety features, drains and curbs, traffic signals, street lighting, landscaping, parking, and all these things. Any features on the road you have to check. So let's just go into the main thing. First, if you see the first picture here on your left, that will be an inclinometer. With this you can check the super elevation, the crosswall. Normally the normal crosswall for a road will be 2.5%. So yeah, you use the inclinometer to check. You can use the inclinometer to check, or we have the other method. This is the theodolite, and by checking we get a level from here and we take a level from here. I think you will be taking geometric subject soon, or maybe some of you have taken it. So from here you can get the level difference and you can calculate the gradient. So yeah, that is one of it example. Secondly, roadway features. So the fat guy here is me. So yeah. So despite whatever it is, you have to wear proper PPE when you're outside. So now this is when we are checking the features, you are checking this will be the pave, this will be the marginal strip here. According to the drawing is 0.25 meter, and then unpaved shoulder will be 1.5 meter. This is what we were checking on it. If you check here, we were checking on the carriageway width, how many meters, and this will be the junction which I showed you the drawing just now. So this is the signage there we were taking, because this is pre-opening, so you can walk there's no traffic there yet. Okay, now next, traffic signing and road marking. So this is how we check. We will check one by one. We will check the dimensions, how far is it from the edge of carriageway, and then we'll check on the dimensions. We will measure one by one. If you measure one by one, you cannot finish it when one day. So what we'll do, we'll do some sampling. If there is every 10, every 20, we will check one, something like that. Okay, next we'll go to road safety features. This is the guardrail. So how is the guardrail spaced, how the guardrail is positioned, and what is the spacing between the post to post. Normally, if it is TL2, it is 4 meter post to post spacing. If TL3 is 2 meter post to post spacing, and the height of the guardrail should be 710 mm plus minus 20 mm. And this is the obstruction markers and everything. So these are the road safety features we'll be checking. So these are the drain. Actually, we are checking whether drain is working or not. I mean the invert levels and everything, but this is a little bit more than our scope, but we had to check because the client have requested us to check on this particular project. So we checked the invert levels, several invert levels here. So these are the drains. The main, for road safety audit, you need to make sure the water flows. The water doesn't stand stagnant on the road, because it can cause aquaplaning. When aquaplaning happen, your car can just skid, and it can cause potential accidents and everything. Okay. Okay. Now for RSA stage 5, we haven't conducted for any of these projects yet. So we are expecting to do somewhere in mid-2023. So it's after post-opening. Okay, so as I was telling you, we will be commenting, and the consultant will submit, and we will give our comments, and the designer will respond to us, and there'll be decision meeting. This is how the summary sheet looks like. It's a very simple thing. We will just put in our comments here. The consultant will reply here. If we are agreeable, then there's no problem. If they are agreeable to us and we are agreeable to them, no problem. If there is any difference of opinion, difference of ideology and anything, we will bring it to the decision of meeting and allow the client to make the decision. Normally, the client will be the Public Works Department, JKR. For this project, the client will be the Recoda, the Regional Corridor Development Authority, but it is managed by the NRDA, Northern Region Development Agency. So with that, I think I have done my presentation. Thank you. Any questions? Thank you.
Okay, thank you very much, Technologist Agilarajan. Okay, I hope all the students and audience enjoyed the amazing presentation. Okay, for now, okay, for those who interested to ask question, you may ask now, or ask question in text box, and Technologist Agilarajan will answer it. Okay, we are waiting for the question. Okay, I want to ask you a question, Agilarajan. Okay, how about the implementation of RSA in Malaysia? Is it compulsory to all practitioners?
For most road projects, it is compulsory. In Sarawak, for the moment, they have made it compulsory for most of the road projects. And normally, Jabatan Kerja Raya, any projects under them, they will insist on having road safety audit. But for Majlis, small roads under the local authorities, normally it is depending on the traffic. First of all, is the ADT. I mean, how much are the traffic flow? Secondly, of the need of the road. If it is only localized and everything, there's no problem. Something like that. So if you say it's mandatory, it's not mandatory, but it is mandatory by several agencies such as MBSA has made it, MBSA Majlis Bandaraya Shah Alam has made it, it's made it mandatory for certain project with more than certain amount of population. And JKR, as usual, they have made it mandatory, and all the federal projects, you need to have road safety audit. Thank you.
Okay, just now you was presented about the safety auditor, right? In Malaysia, it's around 42%, right?
41, sir.
41. Okay, 41.
Yes.
Okay, how about if those who are interested to be an auditor, what they should do?
Firstly, you get your PE, Professional Engineering Certification. Then you have to attend a road safety audit training, the first training. Then meanwhile, you have to work for your PEPC. Then you have to go for your second training. And then you have to work under a road safety auditor for 3 years. And after that, you can get your road safety auditing certification.
The PE is a PPC or just PE only?
PEPC now. But the first training, you don't need anything. You can just go for the first training. You can be an auditor assistant. After that, the second stage, you need to have your PE. Without your PE, you cannot go in.
The criteria, I think, is quite tough, actually.
It is. That's why we only have 41 in the whole Malaysia.
Okay. Okay, the next question is I want to ask you about you. Okay. What would happen in case of design mistake or non-compliant in road design?
Okay. Design mistake. That's why we have basically normally in conventional projects, we have multiple tiers of checkings, reviewings, right? So normally when you have, for Pen, okay, let's take Pen Borneo Highway Sarawak as an example. Pen Borneo Highway Sarawak, the consultant will be designing the project. Then it will be checked by the design management team under the PDP last time, project delivery partner. Then they have a DCE, design checking engineers to check within the PDP as well. And then this is the second tier of checking already. Yeah. Then after that, you have also externally independent checking engineers. They will also give in their comments. And externally, because road safety auditors are independent, so the road safety auditors will also give in their comments as well. So this, in my opinion, this will reduce the amount of mess it can create or the non-compliance and everything. Okay, now, when you have a road safety audit, one of the road safety audit is to function is, for instance, there are a lot of consultants they are still using the old design book for old design standards, the superseded one for designs. So what we do is we will point out, we will tell them, hey, this is the latest book, so you have to use the latest one. So we will comment based on the new book and we'll explain to them, hey, this is what's happening. You ketinggalan zaman sikit, you have to catch up. This is what. So that is part of the road safety auditor's responsibility as well. And again, other than this, the authority themselves will have the people, the engineering team to check these issues. So despite these multiple tiers of checkings, there has been still problems at site when the real thing happens, right? There'll be problems. So when the problem happens, the best way for us to move forward is to find the mitigation. We'll go for mitigations. If you can't find a proper mitigation to that particular situation, then you will have to find then you have to reconstruct or all these things. It'll actually be very costly. So for instance, right, there are places where this is a simple example. Based on the ATJ 86, your gradient, minimum gradient should be 0.5%. So you can go lesser up to 0.35%. And it is also said that you can even go lesser, but the problem is at the places where the curves are, when you have curve, you have super elevation and everything going on, right? When you have that thing happening, you will have, because super elevation, normally your crossfall will be like this, right? So water can flow both sides. So when you have super elevation, this thing will be tilting like this. It will be flat 0%. So you need the vertical thing to actually make the water flow. When you do not comply that, what will happen? Water will be stagnant at that portion and small aquaplaning will happen. What you have to do, maybe the mitigation will be just adjust the super elevation that area, because that wouldn't be that expensive. And some, you can just mitigate it by putting signages. When you have accesses close by, access A to go to a person's house, access B to a person's kebun, right side by side. So, people cars keep on turning in, turning out, right? So it will cause, it can alleviate the potential, the probability for crashes. Yeah. So what you have to do, you put a proper signage earlier. These are the mitigation measures which I'm listing. Yeah,
okay, thank you. Okay, we still waiting for the question. Okay, we have the first question enter. Okay, the first question is from Dr. Andri. Good afternoon. Technologies Agilarajan. Is it necessary for national road in Malaysia to be regulated to have such a free zone at the roadside that will supposedly be used as the recovery zone should a vehicle skid and terbabas? Okay, since we can see most of the roadside at the non-toll road doesn't have the barrier or this free zone. Thank you.
Okay. Thank you, Mr. Andrea. Okay, now, free zone. Okay, normally, wait, let's go to the question again. Malaysia to be regulated such as free zone roadside will be supposedly. Okay, now, normally for rural roads, we will consider it, we call it clear zone here based on RIM guidelines. We have to, in order for you to install, okay, now you're talking about longitudinal barriers here, like guardrails and everything.
Yeah.
Normally we have a calculation. We will have certain amount of, if you have certain amount of distance, a width, clear width there, you don't need to put guardrails or anything. So now his question is, in Malaysia to be regulated such free zone. Actually, we allow free zones to be there. So when skid, it is good for when you have sufficient clear zone. It is good for you to for vehicles which goes out of the road. They can recover and come in. True, but nowadays we don't have that much of space. When you don't have such enough space, we won't have the enough, when we don't have sufficient space, we have to put the guardrails and everything, right? So when your guardrail is a flexible type of longitudinal barrier, so when a kereta terbabas or anything, it can go and it will be redirected into the road. So normally, yeah, we do allow free zone. We do have this free zone. We call it clear zone in Malaysia, but the problem is we rarely have opportunity to use that because we have constraint with land. We don't have enough space for us to have that much of free zone because for certain type of roads, right? This clear zone is calculated by using ADT and also the width of the ADT and the speed of the road, right? So when you do that, you need a huge width of free zone there, clear zone. When you have a huge width of clear zone, it is not workable. We don't have that much of land. So that's we always, when needed, we will put guardrails or any other longitudinal barriers. Thank you, sir.
Okay, thank you. Okay, still waiting for the next question. Okay, for those who want to ask question, if you feel natural to...
Someone, Mr. Joe Bono, has raised his hand.
Okay, Mr. Joe. Mr. Joe raise hand.
Okay.
You can proceed for your question.
Okay. Thank you. Can you hear me?
Yes, yes.
Okay. So thank you for the presentation. Good and informative presentation, Mr. Agilarajan. So my question is, I think as far as my understanding, RSA is more on the design, based on the design measurement, or the safety is slightly based on the design. Okay, so is there opportunities that for post-mortem accident or fatalities that involve the traffic behavior instead of only for the design? Okay, and then I think Mr. Agilarajan familiar with the IREP. Are you familiar with IREP? Okay, so what do you think between the RSA and IREP? Do you think this can be negotiated, or you slightly different with this IREP approach? Thank you. That's my question.
Okay, thank you, Mr. Joe.
Okay, thank you. Thank you, sir. Okay, now, there are two questions I noticed there. The first part is based on the design measures. Yes. First of all, our main, the stage 1, stage 2, stage 3 will be checking on designs, correct? But the stage 4, stage 5 will be more on construction, more on compliance and verification audits. That's the thing. In terms of high reg and road safety audit, okay, for the moment, there is no much of a, there is no clear way of combining it together. However, maybe there'll be is a good topic for future, and we should be able to combine because based on my studies last time, it is mostly the most important thing is human behavior, true, and certain areas where there are a lot of, depending on the areas we need to have their own hierarchy. And it is a very good idea, and it has not been implemented yet, but it's a good topic which I will propose to the road safety auditors, whoever I know, and we will. I think it's a good idea. We should bring this forward. It's a very good idea, and also the post fatality type of analysis and everything. For the moment, I know Plus they do it. Plus Highway, they do it, and they use hierarchy as well. And since we are also involved with them in their analysis, we have normally we will go into by studying this documentation they have prepared, we will go into more into mitigations only. But I think in future it should be good that we should be able to study everything together, because it is interdependent also, the data. With this data, we can propose a better measure, better mitigations. So it's a good idea. Thank you, Mr. Jowono.
Thank you, sir. Thank you.
Okay, still waiting for the next question. Okay, for those who feel natural to ask in Malay, you may ask in Malay. Okay, okay, I want to ask the next question. Okay, Agilarajan, it's about the structure design. Is it RSA cover on the structure design such as bridge, viaduct, based on the certain standards?
Okay, sir. In terms of structure design, we don't go much onto structure because I haven't done any structure for past 10 years, I think. Now, what we'll do is we will comment on the general arrangement of it. We'll normally comment on the general arrangement of the bridge, where we will talk about the lane widths, if there is a median. I mean, we'll talk about the parapet. The parapet is important. We'll talk about the curbs. Curbs for the, normally in bridges, you have walkways, right? So, and you will have the curbs. The importance, we have to have what type of curb. We will have more on a barrier type of curb, so that, the cars will not go and bang the pedestrian walking over there. Similarly, when you have medians and things like that, what type of curb you use is more on semi-mountable. So, if anything, the car can go up and come down back, something like that. So in terms of bridges, we can also talk about what we will do in terms of structures. We will also talk about how, the guardrail just now I was talking, how do we infuse the guardrail into the bridge parapet? That is also important. Normally, the bridge parapet is a rigid parapet, it's a rigid structure. So when you bend, your car will just crash in. Meanwhile, guardrail is a flexible thing. When you bang in, it will flexible, it will divert back. So from flexible to rigid, we need to make a small section of semi-rigid structure. It's a proper transition, you see. So normally, the post spacing for guardrails in flexible portion will be 2 meters, post to post, So what we'll do when it's getting closer to bridge, we'll make, rather than 2 meters, when it's getting closer to bridge, we'll make 1 meter spacing. 1 meter spacing. Then it will go into the parapet. Parapet will be a rigid barrier. And also some areas, if you notice, there's NJBs, New York, NJB, New Jersey barriers. It's also made of purely concrete block, or normally it's concrete block. So when you have that, we also, if there is a guardrail, we have to infuse it properly. So that is an example. But in terms of structure, we do not comment on the structures at all. Thank you.
Okay, thank you. Thank you, Technologist Aji. Okay, we have a number of questions here from text box. Okay, good afternoon. I want to ask about your opinion regarding Brotherhood, a volunteer group that repair pothole problem in Malaysia? Thank you, technologists. Okay, what do you think about it? Is there? I think the question is there the what do you call it? The volunteer do the repair of the road, achieve the minimum requirement of the PBT.
Okay, so first of all, since I'm based in Sarawak for the past 7 years, I'm not familiar with this brotherhood and their outcome of whatever they've done. But in my point of view, I would like to applaud this personnel for taking the initiative. But this initiative should be done by the authorities and people with the knowledge, because potholes just don't happen. There will be a real problem. We have to investigate what are the problems. If you go to the manual facility, the best way is for you to know is there's a manual facility, a red book by Ikram. If you read that book, it has it shows why and how it is why the pothole comes into picture. But I'm not sure this particular personnel under the brotherhood whether they are aware of this or not. If they are not aware of this, it is better to let the professionals to handle it, because sometimes when we go and do things which we are not competent in, we may create problems. Sometimes it is good, there's no problem, but sometimes we tend to create more problem because there'll be water or anything which has entered into the subgrade, which will make the subgrade even weaker. So if they have not cleared the problem is still there. So yeah, that is my opinion on this. And I can't comment much because I'm not aware of this. I'm very sorry, sir.
Okay. Okay, the next question is from Prof. Dr. Chan Chimeng. Okay, great sharing there, Mr. Agilarajan. Okay, in your view, what would be the best way to improve road safety in Malaysia among reckless drivers? Thank you.
Okay. Thank you, Dr. Chan. How are you, Dr. Chan? I used to be a student. It's a pleasure hearing you asking questions to me. Thank you very much. Okay, Dr. Chan, my view on this is basically education, Dr. Chan. So first of all, we can increase the penalties and everything, but problems like this will still arise because we have our road networks here are more used because our public transportation in Malaysia is not as competent compared to all the first world countries. So people will still tend to use cars and private transportation. In my latest study, I've just found out that in Sarawak, the ratio between private car ownership and the population is 1:2. So 2 people own 1 car. So you should know the number of cars are available in a small city like in Kuching. I'm sorry, not in Sarawak, in Kuching alone. So you see the number of cars. So number of congestion can happen. So yeah, again, it goes back on, first of all, is on education part. Maybe we should people should be educated on road safety. And secondly, in my opinion, is to have a better public transportation, more integrated transportation system in Malaysia, which I believe the government is actually planning for the moment. But maybe in next 10 years time, you'll have it. I'm not sure. But in Sarawak, we are doing something called Kuching Urban Transportation System, whereby they're integrating the whole transportation system in Kuching, and they are covering all the major cities. They are doing it in Kuching first. In future, they'll be doing it in Bintulu, and they'll keep on going to all the major cities to curb the urban congestion. So the 2 ways, in my point of view, is first is education. Secondly is better public transportation, rather than imposing higher penalties, because end of the day, people will find ways to pay off, or there will be a big discount, a big summon discount of 50% or 70%. People just rush to pay and settle it off. So that's my point of view, Dr. Chan. Thank you.
Okay, the next question is from Muhammad Amir. Okay, good evening, Doctor. My name is Muhammad Amir. This one, I have a question. Is it possible for Malaysia to also have a musical road, just like Netherlands? If possible, what is the benefit? Okay, I think this is an interesting question. Okay, I don't know about the musical road. Can you answer this question?
I've heard about this musical road before, but maybe we can have it for all the scenic type of road, scenic, where people drive slowly just for the scenery. If in Sarawak, if you come to Sarawak, there is a place called Damai in Kuching. So if you drive there very slowly, that it's a beautiful place whereby you have a proper canopies of trees covering, which is also considered a hazard, but as it's also a hazard, but still, it's very nice when you drive under the canopy. It's very beautiful scenery. Left and right, you can see beautiful rivers, beautiful nature and everything, So there are a few areas you can have that. Maybe you can have the musical road, but however, with the economical situation, economically, it is not feasible, first of all. And secondly, where I'm not sure we do have the demand or not for us to supply such things in Malaysia. It's always about the demand and supply. So if there is demand here, maybe maybe people can look into this. But it's basically demand and supply, right? So we are not sure whether we have the demand in Malaysia or not. And plus, Malaysia is a huge country where we have about thousands of kilometers of highway as a backbone from Malaysia, from Bukit Kayu Hitam to Johor Bahru. And in Sarawak, you have 1,015 kilometers of highway just in Sarawak, from the tip of Sarawak to Miri. And then you have the SSLR roads, and then you have the Pen Borneo Sabah is huge. So, and maintaining such highways are huge and it's big money. The maintenance are believing in providing this musical road, maybe it can be privatized and there may be potential benefit to it, but I'm not sure. Probably psychologically it's good or what, I'm not sure. Thank you. I'm sorry, I can't answer the question.
Okay, the next question is from Technologies from ISO. I think from ISO been Ismail. Okay. Hi, Technologies. Understand that Pen Borneo using highway information modeling, HIM. Okay, any way to do simulation for safety road for the project before start?
Okay, sir. Yes. Thank you for highlighting this, because HIM was the first place in Malaysia the first organization which introduced HIM in Malaysia will be Pen Borneo Highway Sarawak. Sadly, the HIM was not fully explored at that time because it was just at infancy. They were just starting to implement it. We did not go into this far into the safety, into the simulation of for safety roads, road safety and everything, because these simulations will be done by the traffic consultant, and apparently they did not in Pen Borneo Sarawak. We don't have in-house safe traffic consultant that time who can do the simulation. And normally this HIM is also, they use the BIM software facilities as well. I believe that they do not have that thing at that time. I don't think they have it now also in order to do the traffic simulation there. But we can, the good thing about BIM, we can upload documents, we can do our simulations and everything, and we can upload it there for the designers, the contract people and everyone to view. And from there, they can think about the solutions or mitigation to it, and then they can add on to it. Thank you, sir.
Okay, thank you. Okay, next question is from Technologies Irwan Sani, I think. It's from Pusat Pengajian Diploma, actually, I think. Okay, good afternoon, Technologies Agilarajan. Nice to see you. Is Irwan here? Okay, I would like to know how long it takes for you to conduct RCA 1 to 4 for this Recoda project?
Hello, sir. How are you? It's nice seeing you here also, sir. Thank you very much. Okay, now, for this Recoda project, because we have 11 projects, okay, Recoda projects, overall, there are 200 over projects. For these particular projects, each package, we have package 1, package 2, package 3. Within each package, you have we have project 1 to project 11, project 1 to project 18. Within each project, you have sub-projects as well. So there are a lot of projects. So it depends on when you're kicking off the project, first of all, how urgent is the project and everything. It depends on the commercial need as well. However, to answer this question, normally when the consultant gives us the drawing for the report first, they will give us a feasibility or conceptual report for stage 1. Will take 2 weeks. Will take 2 weeks to check the drawing review, and then we submit back. We'll give them another 2 weeks to check, to respond to our comments, and then we'll go for decision meeting with the client. So approximately it's about a month plus per session, per stage. So normally per stage, and they will also need time to design, and also wait for their survey data, their both SI data, and all the other elements also. So approximately 2 months per stage. So 2 months for stage 1, 2 months for stage 2, 2 months for stage 3. Then the compliance audit can prolong it if they want. But the compliance audit must be done before tendering of the particular project. So that is stage 1 to 3 up to compliance. Stage 4, part 1 starts upon tendering, upon the contractor at site have commencement of their work. They're commencing, so they will give us their TMP, traffic management plan, for us to review. Normally, traffic management plan depend on the size of the project. If the small size project, it will take us like a week to review, and a week for them to respond to us and to rectify things at site. So that's another 1 month or another 1 to 1.5 months. And then stage 4, part 2 will be done at the 50% progress of the construction. So if the project is scheduled for 3 years, maybe it is done at the first 1.5 year. We will do that audit. Okay, the audit is we will do for stage 2 or stage 4 part 2 audit. We'll do a morning audit and night audit. We'll go in the morning. We'll go for verification audits and everything. At night, we will go again. We will drive along the side, along the road to check the retro-reflective of the signage and everything, whether at night is visible or not, the visibility and everything. And stage 3 also similar. We'll do morning audit and night audit. Normally the audits 1 whole day from morning to night. The next, then we'll take 2 weeks to prepare the report and everything. Then finally, once we consolidate everything, we will submit it to the consultant, or the stage 4 will be submitting to the consultant and the contractor for their response. Thank you, sir. So that is the answer to a short answer to the question is there's no specific timeline.
Okay. Okay, we're still waiting for the next question. Okay, before that, okay, I want to ask you a question about the design. Okay, the accident occurred on the road actually. Is it possible because of the lack of attention to design process? Is it possible lack of attention to design process?
I would not discount that particular reason. Maybe there is. Maybe there is.
Maybe there is.
Maybe there is. It can be one of the cause as well.
Okay, the most cause is about the driver attitude, right?
But those things are very qualitative data. We cannot prove it much, you see. Normally it is what is happening nowadays, we need proof, right? So it's either qualitative or quantitative. Quantitative data are easier to prove. So people, there is no enough studies on the qualitative data. As I remember in UPM, Professor Dr. Lee in the engineering faculty transportation department, he was doing some studies on that. But I believe he's still doing some studies on that to prove to get more on qualitative data on drivers' behavior. Was also supported by Dr. Hussein in UPM as well. But however, he has passed. It's a quite saddening news. So, but these people were trying to get some data to prove this. So we do not have sufficient data to actually say if the drivers is thing, but it is obvious. It is the drivers. I mean, it's driver behavior, attitude.
Okay. Okay. If there are no question, okay, then I want to make a conclusion. So from the technology Agilaraja presentation, I can conclude that road safety audit is the systematic process of examining the planning, design, and construction of the road, and then to identify any potential unsafety features or operational arrangement that may adversely affect the safety of any road user. Right. Okay, I think that's all from us. There's no more question here on the text box. Okay, I pass back to the MC to proceed the next session.
Thank you, Technologies Agilarajan, for the sharing, and IR Technologies Muhammad Hairi bin Uthman for being our moderator for this slot. Next, we would like to invite ladies and gentlemen for the online photography session. We're all asked to open the camera. Don't be shy to open your camera.
Hello. Okay. All right. So smile. 1, 2, 3. Okay. Next. 1, 2, 3. All right. So that's it. Thank you, everyone.
With that, we end our sessions today. Kindly ensure all participants fill up the attendance form as attached in the chat box Zoom or Facebook comment. Thank you and see you on the next slot 5 tomorrow at 10 a.m. to 12 p.m. with the title Industrial Building System IBS. Bye, see you tomorrow. Saya.